Good morning. And the last video I recorded was about hypothesis testing, and today we're going to be looking at a slightly more complex situation where we're comparing groups A and B. That's what A/B testing is about. We have a grouping variable and a numeric variable, and we're comparing the two groups. Okay, I will also say that all of the information, the notebook that I'm going to be using is actually Lab 6, so this will help you with the first portion of Lab 6. You've already seen this slide if you watched the other video. I don't want to make too big a deal out of it, except that we have a null hypothesis, which sets up a probability experiment, and that's where we get the p-value. And in hypothesis testing, we always have this criteria that the p-value comes out, and if p is less than alpha, we reject the null. Okay, if we reject the null, that means we have evidence for the alternative. Okay, or we fail to reject the null, and we have evidence for the null. Okay, so in this example that we'll be running, it's kind of funny. So let's just talk about A/B testing before we talk about the example. So I said it operates on I said that it's got a grouping variable and a numeric variable, and it's important that they go in the right order. Right, the grouping variable is in the first column and the numeric variable is in the second column. And we have to put them that way. Why? Well, you'll see in just a second. And what we're going to do is we're going to compare the average values between the two groups. Okay, so the example we're going to use is, do biological males exhibit a greater number of narcissistic traits than biological females? All right, again, this data was collected about 10 years ago at the University of North Georgia, the Dahlonega campus. And the math professors who are teaching the course, we've written three functions that are going to be of assistance. So AB diff, and this may not be too surprising given that we're comparing the means. The AB diff is going to find the difference between the means from group A and B. Shuffle, you'll see we'll actually shuffle the grouping variable. We'll talk about what that means, and then AB hist is going to produce a visualization of the results. I'm sorry, I misspoke, and instead of Lab 6, we're in Homework 6. Both of them are due this week, and this will help you get homework, the first part of Homework 6 done. So let's go ahead and initialize and pull in the table. Again, this table of personality variables and some demographic variables was collected at UNG about a decade ago. And so A/B testing is what we're trying to do, and are males more narcissistic than females? That's the question we're trying to answer. So in an A/B test, our hypothesis setup is that the group means are equal. So if we have null hypothesis mu sub f for the females equals, sorry, this was supposed to be, sorry. So we have a colon. That mu with a subscript f for the biological females is equal to the average narcissism score for the biological males, right? So that's our null hypothesis. The null hypothesis always has an equal to in it, and it defines the probability simulation that we're going to run. Okay, and our textbook does cover this A/B testing in chapter 18. It's actually a very entertaining read. And so we've got some options, and it asks you to guess ahead of time what's going to be the option 1, 2, or 3, whether the males will exhibit higher levels or the females will exhibit higher levels, or if there's no difference at all in the levels. And then, like I said on the slide, there are these toolkits. And the first one is AB diff. Okay, so what does this do? This just uses the group, the dot group, with the NP average to get the average for the two groups, and then it's using the dot column and item to grab the averages out of that group table, and then it's subtracting them. That's the difference between group A mean and group B mean. And by the way, it does them in alphabetical order. So it's going to do females first, and then that'll be group A, and then males will be second, that'll be group B. And that will be important in a little bit. Okay, so the notes are helpful. Let me point out especially that the function ABDiff expects the first column to be the grouping variable, right? So first column grouping variable, second column numeric variable. Okay, so what we're going to do here is an example to demonstrate how it works. So if we're going to use these tools that we've been given, the ABDiff, the ABShuff, and the ABHist, we are going to need to create a two-column table. All right, we already know how to do this. We're going to use dot select. So let's hit Shift Enter to make sure that that ABDiff function is ready to go. And then we're doing what? We're from the personality table, we're selecting sex, that's biological sex, and narcissism, NARC. So it gives me a two-column table just like I need with the grouping variable first. Now let's apply the ABDiff to our new table. And so we find that when it calculates the difference, right? Remember, it's got the female average and it's got the male average, and it's subtracting F minus M. So this minus 1.7449 that it comes up with means that the male's average is higher. It's subtracting a smaller number, a larger number from a smaller number, so we're getting a negative number. And again, the note is made here that the computer is going alphabetically. So we know that that negative number that we get when we subtract is females average minus males average. Okay. So AB shuffle. All right, so we're going to define this shuffle function, and I'll show you what it does in just a second. But it shuffles the grouping variable. You can even see shuffled grouping. And it's expecting the same thing. It's expecting a table with two columns, and the first column is always the grouping variable, and the second column should be the numeric variable. All right, well, we already have that created. And so let's just show the narcissism table. Okay, we've noticed that we have males, female, male, female, male, female, male. And notice the numbers are 11, 11, 11, 10, 10. Okay, so those are the narcissism levels for those individuals. Now notice what happens when we do AB shuffle. Okay, now instead of them alternating males and females, we have a female first and then 4 straight males. But notice that the numeric column has not changed at all. Okay, so what is AB shuffle doing? It's just randomly rearranging the grouping variable. Why? Well, so we're going to create a bell-shaped distribution of these differences, and we're just going to randomly reassign male and female to just any data point that we want, or not that we want, but just randomly. We're doing it randomly. And then we're going to recalculate the AB diff. So it's gonna shuffle all the group labels, which means it's going to change who's in the group, which means the averages are going to change. And sometimes the females will have a higher average, and sometimes the males will have a higher average. It's just always going to get randomly shuffled and then recalculated. It's a whole lot easier to see the picture. Okay, but notice that the grouping variable column is shuffled. And so what happens? Boom. Okay, now the very first thing we notice is that we had, remember before we had the negative 1.7, I think it was 1.744, but that's what we had before in the original table. Here's the shuffled table. It shuffles the narcissism table and it calculates the difference. And now we have a positive 1.17, but it says execute the code block several times to see what happens. Okay. And now we have 0.28. Interesting. That's also positive. So let's shuffle again and calculate the average, 0.25. Oh, and there it went negative. Negative 0.16 and negative 0.132. Okay, so that's what's happening with AB diff and AB shuffle. It is randomly shuffling the group labels to different data points and then recalculating the difference between groups A and group B. Why are we doing this? Well, let me show you as we go down. Hopefully it will, as we go further down the notebook, hopefully it will become clear. Okay, so AB his, let's create our last function. And so I'm just gonna execute it so that it's entered in the computer memory. The function input requires two things, an array and an observed value. Okay, the for loop is going to generate the array, and the observed value is going to be the AB difference from the original data. Okay, so the for loop. First, let's create a variable observed difference. So we're going to need that, right? The observed value. So we're going to do that first, and it's right here. Boom. And remember, it has the original negative 1.7449. It's got that from before. All right. And this is the same thing. Just skip past it. Now, we need to create an array of output values. That's the thing we need, an array of output values. We want to shuffle the grouping variable over and over, and the array will record the results. Okay, so notice that narc differences is an array. At the moment, it's an empty array. And then also, please read this. If you're doing this, please set your reps to 1,000 or less. I set it at 1,000. Okay, why? Well, because if you're running this in the cloud, it could take a while. And if you set it at 20,000, it might take 20 minutes or 30 minutes for it to run. And we don't want to just sit here watching the computer do nothing while its memory spins round and round. Okay, so what are we doing? So it's going to go in this range reps, right? So reps is 1,000. Basically, it's going to count from 1 to 1,000. It's going to do this. It's going to do this thing 1,000 times. And what is it going to do? Well, it's going to calculate first this code block above that we repeatedly hit Shift Enter on to watch it run. It's going to do that, and it's going to assign the mean difference that it gets from that calculation to a value called new diff. And then new diff is going to be appended. So np append is going to take this array and add this new value on the end. And then we're going to go back up to the top and start this loop again, calculate another value of new difference, and then put that value on the end. So what's going to happen? Well, we're running this 1,000 times, so we're going to end up with an array of 1,000 values. And each of those values is going to be the difference between a randomly shuffled group A and group B, the average, the difference in the two averages. Okay. And so let's run it. It will take a moment, more than likely. Okay, and notice that it actually gives you a hint. To use the above code on another data set, change the variable name and change the table. Right, so again, we're going to have to download a new table to get data from, and it's saying that we're going to need to change narc differences. Okay, so then let's run the results. We've run the for loop, we've done everything, and now when we run AB hist, we see what's happened. This is what I was telling you would be bell-shaped. This is the differences of the mean values. Okay, notice that it's centered around 0. Okay, and when we randomly shuffle the group labels, sometimes we get high values in, all the high values go over for the males and we end up, way over here. Or sometimes all of the labels for the high values are assigned to females and we end up way over here. So the bell curve is just showing all the results of those 1,000 trials, those 1,000 observations. And let me get rid of my red mark so you can see the red mark that the graph makes. So that's our observed value of negative 1.7. So how likely is that to occur? And just like in the previous video, yes, is there a tail in this distribution that's out there, and is it possible to shade to the left? Well, yes, if we could really blow that up and see it, we might be able to see something there. But let me just point this out, that we're expecting the p-value to be close to 0. Why? Because we can't see any of this tail of the distribution to the left of it. Okay, so view the output above. The red vertical line shows the observed value. And then they ask you to estimate the probability. And then we're going to calculate the probability. Now this is interesting. I'll just point out that we're going to copy paste this later, but this less than or equal to is assessing whether or not the values in the NARC differences array are less than or equal to the negative 1.7. Okay, and the sum is adding up all the number of times that this is true. So out of 1,000, what is the number of times that the NARC differences, the narcissism differences, were less than or equal to 1.7? And it turns out 0 of the times. We ran the for loop 1,000 times, and in none of those 1,000 times did we see a value that was as low or lower than the negative 1.7. So what are we doing here? Well, we're calculating a probability. We're taking the number of successes, which was 0, and dividing by the number of reps, which is defined up above in the above the for loop, as 1,000, and we're calculating the p-value, and the p-value is 0. Now theoretically, is it actually 0? Probably not. It's one of these where p is probably really close to 0. So you saw me, I said approximately equal to 0. Again, it's going to be one of those p-values that switches to scientific notation with a times 10 to the negative 15th, like in the previous video. But in this case, it's close enough to 0 that we can say approximately 0. Oh yeah, and the notebook is actually saying, yeah, the probability is approximately 0. Okay, now there are some questions that I'll leave to you. And then you get to evaluate your guess from question 1. And then I want to point out the practice problems. So the practice problems have 4 possibilities where you can study perfectionism along with male and female. So sex is correct here. This one says to use the G21 variable, but notice the wrong variable is left in here. So you're going to have to change sex to G21. It will work the same way, but this is incorrect because it's saying to use the G21 variable. This one is also requiring the G21 variable, so we're going to do the same thing down here. But basically, it's just saying, hey, you need to pick at least one of the following problems and do them. And what are we going to do? We are going to copy paste from above. We don't have to copy paste the AB shuffle and AB diff and AB hist. Those are already loaded into computer memory. But we need to create a new table, and these are giving us some help on how to do that. Okay, so there are values down here. There are open cells down here, or you can open cells down here, and you're going to select something, and I will throw out optimism. So let's do biological sex and optimism, and let's do show 5 just so we don't spend a whole bunch of time on looking at rows of this table. Boom. So notice that we have a 2-column table. This is exactly what we need with the grouping variable first and the numeric variable second. And then to run the test, so just to set this up real quick, right? So our null hypothesis is that the optimism levels for females is identical to the optimism level for males. Okay, and our alternative hypothesis is going to be that there's a difference. So mu sub f is not equal to mu sub m. And notice I've chosen one where where we won't have to chop the p-value in half. Okay, we can just run it. So what do I need to do? Well, the first thing I need to get is some observed difference. So I'm going to run observed difference equals ab underscore diff. Oh, and I need to name this something. Let's call it optimism equals. Okay. And I'm going to do AB difference of the optimism. Boom. And it's throwing an error. Oh, the show 5 is messing it up. Hang on a second. So if I do this, the optimism dot show 5 down here, it'll still show the table, and then it'll still run this without an error. And then I can actually do observed diff to show the value. And so the observed difference, remember, it'll do it in alphabetical order. So the average value for the females minus the average value for the males is negative. We see this negative 0.63. Okay. So what do we do next? And notice I haven't done any of the 4 that are listed for you here. So I'm just doing another example, but I'm showing you exactly what you're going to want to do. You're going to want to come up here and get this for loop and copy paste it, right? So I'm going to copy the for loop code block and put it right here. And I'm going to change this name. That's what it says to do, to change the name. So I'm going to do OPT diffs. But notice that I also have to change the name of the table that it's going to look at. And I also need to change narc to OPT there and narc to OPT here. So there's 3 places where I have to change narc diffs to OPT diffs. All right. And everything else is the same. Reps is still 1,000. I've changed, I also need to change the name of the table that it's going to look at to optimism. And boom, it runs it. And it's taking a second. Okay, and then I want to run AB underscore hist. Now, there are 2 things, and it's important that they go in the correct order. So I need these OPT diffs. This is the array. Okay. And I need the observed difference, which I just calculated up here. I need that to go into the AB hist. And then it shows a nice histogram. But notice this red vertical line showing where the observed difference was actually falls right in the middle of the bell curve. So it's actually pretty likely to happen. Okay. And how likely? Well, let's go grab the, let's go grab this and copy paste it. Why? It'll just make more sense that way. Now we want to take the OPT diffs minus the observed diff. Excuse me, and check to see whether it's less than or equal to. Boom. And we got 237. So what we want to do to calculate the p-value is take this number, which is 237, and we want to divide by reps, which is 1,000. And I also want to print out what P is so you can see it. So the P value is 0.237. And notice it doesn't matter if we were using a one-tailed hypothesis because it's still, half of that is still greater than 0.05. And so we fail to reject the null. And what do we know? Well, we have evidence that the biological sexes are about the same on optimism. We don't have any reason to believe there's a difference on this particular variable. All right, so I just wanted to show you that all we're trying to do while you're being asked to do is saying, look, make a 2-column table that addresses the question we're supposed to address, get the observed difference, copy and paste the for loop, right? And then when you do the A/B hist, you'll get this output. And if you want to know exactly what that p-value is, you can copy paste this summation and then divide by the number of reps. Okay, so this should be a lot of help on homework 6. Good luck.